Hello friends, welcome to Shiksharthi. In this session, we will be talking about the conceptions and the misconceptions on the topic, what is a function? So let's start. Now, when we are talking about conceptions and misconceptions, I hope that you are already aware of this series of ours wherein we address the misconceptions on the topic with the help of the concepts, and we build up the concepts to remove the misconceptions. Okay, so for that, it is very necessary that you go through all the sessions that we would have done earlier on the topic like functions, basically talking about the domain and the range of the function. So here, let me put the subtopic or the main topic that we are going to talk about here is a function. What is a function? Now, when we are addressing the point, what is a function? In that case, it becomes important to address this topic with the help of domain and range. So we know that the domain is the launch pad to a function. This is something that we have already discussed in our earlier sessions. It is a kind of launch pad. It gives a unique identity. Another way to understand this is it gives you an identity. The other is it gives you a unique identity. Okay, so I'm writing down four things here. One is, and we are aware of the fact that the domain is represented by the independent variable x. So now when I am giving different values to x, what are the different values that we can give? Either we can give unique values. Now the moment I say unique values, actually what I mean to convey here is different. The word unique itself means single. So we are talking about different values. So either we give unique values or we give the same value, which is non-unique values. So when you're saying non-unique, you're basically saying not different. Not different means same values. And accordingly, you will get either unique values for the range. So when we talk about the range we know is nothing but the dependent variable y, which is nothing but the destination point. We call it as a destination point because it defines the destination. Defining the destination means it gives the value to it. So it is nothing but the destination point. Okay. So analogously, we can say that when we are talking about y, we can get unique values for y. Or we may get non-unique values for y. Now using this matrix, which matrix am I talking about? Using the matrix, now let us say that what I intend to convey here is, let us say that this I am taking it as 1, this is 2, this I am taking it as A, and this I am taking it as B. I mean, let me clarify what I'm trying to say here is, let us say if I give unique values to the domain, that is the first of its kind that I am taking, which is denoted by 1. Second case that I am taking here is non-unique values, wherein I am taking the same values for x. When I take the same values for x, is just like saying x is equal to 1. And then when I'm talking about the range values, then the the first case that I'm talking about, in which I'm going to take the unique values for the range, is represented by A, and when I'm taking non-unique values for Y, which is the range, that is being represented by B. So in total we will have 4 different experiences. Let us talk about how many experiences would we have in total. We will have 4 different experiences. The first experience is an experience in terms of X to Y. First experience that we would have here is 1 to A. Second experience will be 1 to B. Third experience here would be 2 to A. And the fourth experience here would be 2 to B. Let us understand this further with the help of some examples. If we can take some examples here. So the first example that I'm taking here, which I'm denoting it by Roman number 1. Let's say I take fx is equal to x. Now in that case, let me say that the value x1 I am taking it as -1, x2 I am taking it as 0, x3 value I am taking it as +1, and so on. Now what are x1, x2, x3? x1, x2, x3 are nothing but the subdomain. I mean, these are the domain values, various domain values being represented by x1 is the first such domain value, x2 is the second such domain value of fx, x3 is the third such domain value. So can I say all these domain values are unique? Yes. So all such domain values are unique. And then let me say this is either equal to fx or y. So what is the first such range value that I'm getting from here? -1. What is the second such range value that I'm getting from here? 0. What is the third such range value am I getting from here? +1. So can I say even the range values are unique? So this case boils down to which case? This is 1 to A, wherein you have unique domain values and the unique range values, and we call this as a 1-to-1 function. So one value of x giving me one value of y, another value of x giving me another value of y, and so on, if this thing keeps on happening throughout the entire domain and range. It is then that we say that this given function fx is a 1-to-1 function. Let me take a second case here, wherein I am taking a function as gx is equal to x square, or I am taking it as y is equal to x square. Now in this case, in the interest of time and the interaction that I am having with you now, since I have already explained what is x1, x2, x3, so let me say that these are 3 different domain values that I am taking. Now the domain values itself certify that the function is defined for all such values. And what are the range values that I am getting from here? So +1. In the second case, the range that I get here is 0. In the third case, the range that I get here is +1. So you would see that -1 is not equal to +1, but then the range are equal. So what is this experience? This experience is you're taking unique values for the domain, but the range has non-unique values as well. I repeat, the range is non-unique. Even if I know that range has 0 also, it has 1 also, it will have 4 also, but then you'll have at least one pair of domain values giving the same range, at least one pair. Which kind of an experience is this? The experience is a very obvious one, which is the range values are different, but the domain values are different, but the range values are not. And such a function is known as a many-to-one function. Wherein you are taking many values of x, but you are getting a single value of y. Okay, the third case that I'm taking here now is I have taken a function like, let's say I'm taking y square is equal to x. Now when I'm taking y square is equal to a x, it's just like saying, I could have said that this is nothing but just like saying you take a function fx, you take the square of this function which is equated to an x. So let me take the different domain values here. Let me say x1 is equal to -1, x2 is equal to 0, x3 is equal to +1. What is the experience in terms of domain values? So the experience in terms of domain values is unique. So now before you do this, you'll say that instead of assigning values to, maybe, I mean, you can take different values, but before I typify this as unique values, maybe there is some more introspection which is required. So before we typify that these values of x gives me a unique experience in terms of unique values, there is more introspection that is required here. And the introspection says, instead of taking the values of x first, we should have taken the values of y first. So you would have seen that if you take the value of -1, in that case, the first such domain value comes out to be +1. Even if you would have taken the range value as +1, in that case, the domain again would have been +1 only. So you will say that ultimately the experience here for the domain is a non-unique one, but the range has a unique experience. There is a unique experience. Now, if I were to typify this experience altogether, the domain experience is non-unique, but the range experience is a unique one, which falls under the third category that we have talked about. So, what is this ultimate experience known as? This is known to be a one-to-many function. So if I were to finally check which among these is going to be a function, is this a function? Yes, it is. Is this a function? Yes, it is. Is this a function? No, it is not. Is there any other experience other than the three experiences that we have talked about? So there is one more experience which remains here, is wherein when the range also is non-unique and the domain also is non-unique, maybe a point-to-point function. So any other such experience will not fall under the category of a function. So what is a function? So what the misconception, or once fresh concepts have been brought into picture, I as a learner, I have learnt that a function will be called as a function only and only if it has a unique domain wherein all the domain elements should be different for either the different values of the range or the same values of the range. And the best example that you could have taken for a many to one function is a constant function, wherein if I say fx is equal to 0, in that case the domain is real numbers, but there is a constant range which is equal to a 0. Hope this session on on conceptions and misconceptions helps you to remove the dust and take your learnings to the next level.